Hi, welcome to Sunil Maths tutorial. In this video, we solve a problem from Riemann integration. Let us see the problem. Prove that the function f of x defined on closed interval 0, 1 as f of x is equals to 1 if x is rational, minus 1 if x is irrational, is not Riemann integrable. Right? Let us prove this. They given that f of x is equals to 1 if x is rational, minus 1 if x is irrational. So clearly the function is defined over closed interval 0, 1. So right, let us take capital P is equals to 0, it is equals to x naught less than x1 less than x2 less than and so on is less than xn is equals to 1, be a partition of closed interval 0, 1, and define infimum and supremum like this. Define small mr comma capital Mr be the infimum and supremum of the function f of x on rth subinterval ir, which is defined in this way: closed interval xr minus 1 comma xr, where that r is varies from 1 to and so on n. So right, now by using this infimum and supremum definitions, it is clear small mr is equals to minus 1, which is known as infimum, and capital Mr is equals to plus 1, which is a supremum of the function f of x on the rth subinterval. Now we calculate lower Riemann sum and upper Riemann sum, LPF and UPF. LPF is equals to lower Riemann sum summation over r is equals to 1 to n small mr delta r. What is delta r here? The length of the interval. Delta r is nothing but length of the interval 1 minus 0, which is equals to 1. And small mr is also minus 1. So you simply get this value becomes minus 1 summation over r is equals to 1 to n delta r. So which gives a result of minus 1 into 1, you simply get 1. Now in a similar manner, let us calculate UPF. UPF is equals to summation over r is equals to 1 to n capital Mr delta r, which is equals to capital Mr is equals to 1. So you get summation over r is equals to 1 to n capital Mr 1 into delta r, which gives a result of simply 1 again. 1 into 1, you get 1. So LPF is equals to minus 1 and UPF is equals to plus 1. Now calculate the lower Riemann integral. Integral a bar to b f of x dx is equals to, by the definition of lower Riemann integral, supremum of LPF such that p belongs to pi of closed interval a comma b. So you observe that where pi of a comma b is nothing but the set of all partitions defined over the closed interval 0, 1. Here this is nothing but a is 0 and b is 1. So again this is simply equivalent to, because of our calculation already, LPF is supremum of LPF. So already we get this. I'm sorry, this is minus 1. Last time I calculated it is plus 1. This is minus 1. Minus 1 into plus 1, minus 1. So you simply get here minus 1 it is. Now go for upper Riemann integral, integral a to b bar f of x dx, which is equals to infimum of UPF, infimum of UPF, such that again p belongs to pi of closed interval 0 comma 1. So which gives a result of 1. It is very clear, integral a bar to b f of x dx not equals to integral a to b bar f of x dx. It means lower Riemann integral is not equals to upper Riemann integral. This shows us the function f of x is not Riemann integrable, not Riemann integrable over the closed interval 0 comma 1. Here we observe that here both the limits, because of the function defined over closed interval 0 comma 1, so a is equals to 0, b is equals to 1. Anyway, upper and lower Riemann integrals are not equals to one another. This gives a result of the function f of x is not Riemann integrable over the closed interval 0 comma 1. That's it. In the next video, we solve a similar problem in the Riemann integration.